Okay, good morning everybody. Today's lecture is a continuation of IC engine. So first part you have seen this different strokes, cycles, different calculations. The second part this week will be discussing more on theoretical aspect of fuel properties, lubrication properties, cooling system, engine cooling system, how to cool because temperature will be going beyond 2000 degrees centigrade. But your melting point of piston in cylinder or piston or piston ring will be 1200 800 degrees centigrade. So at high temperature it should not get melted, so you should remove the heat from the system as soon as it is getting generated. Now the heat source will be fuel. So how to burn the fuel? You need oxygen and mixture of fuel and one fire source or compression. Ignition temperature you have to reach, then fuel will be burning, you will get lots of energy. So that energy will be the fuel generated energy will be used for your power production, or you will get torque from that. From torque will be supplying power through this shaft. You can see the picture. Okay, this is your engine. Okay, there will be gearing mechanism. Why gear will be required? Because gear will be reducing your speed. Okay, so normal IC engine speed will be more than 200 rpm. Now propeller speed will be less than 200. Okay, so you have to reduce the speed. So for that purpose you should have one gear mechanism. So the gear mechanism will be here, and this is shaft will be connected to your propeller. Okay, and the topic basically I have taken from D.A. Taylor book or R.K. Rajput book. So now whenever you are talking about marine engine, so marine engine there will be steam powered engine. I'll discuss uh, in week 4 and 5 I think. Then nuclear power engine I'll discuss later. IC engine we are discussing. Biodiesel fuel also there. Recent engines are there with biodiesel or alcohol based diesel engines also will be there, or biofuel engine. Those are also IC engine actually. So instead of diesel or petrol, you are putting some percentage of alcohol or other hydrocarbon based fuel. Alcohol also having carbon as a content. So whenever you are talking about fuel like fossil fuel, so those are having actually carbon content. So carbon will be reacting with oxygen, it will be creating carbon dioxide. It is exothermic reaction, it will be producing lots of heat, so that heat is required. Okay, gas turbine engine we'll discuss later. Fuel cell engine we'll not discuss, but we'll see if we have time, then we can discuss something. Solar power engine also there. Electric power, battery power, these are recent engine people are developing. Gas fuel, so instead of liquid fuel, gas fuel engine also possible. Wind power, already you know, this is older engines, human powered or wind power engines. Okay, so basically we'll discuss in this course steam powered cycle, nuclear, IC engine and gas turbine, these cycles. Okay, so some discussion we can have related to solar or electricity based system, but later we'll see. Marine engineering, marine engine, if you see in diesel engine, I think 1892 diesel engine got invented, and 1930s two stroke engine dominated. Okay, later four stroke engine dominated. Then finally what happened is steam power ships replaced by motor power ship. Motor power ship means like more on IC engine based system, or electric power now which is coming, electric or solar power. Okay, so gradually the transformation is happening. Initially it was like human powered or wind powered, then IC engine came up, coal powered or internal combustion engine powered, then slowly in turbine came up or reciprocating engine came up, then diesel engine, petrol engine, then recently steam ships are being replaced by your combustion IC engines. Okay, or gas turbine engine or nuclear powered engine. Nuclear power engine also having limitation because of reactive nature. So basically warships and other ships they will be using nuclear power, but gas turbine engine also very common for big ships, heavy machineries. So crude oil formation to refineries to your engine. Okay, so crude oil formation. So you know that thousands of millions of years ago, lots of algae, flora, fauna, all these things got deposited, and those got transformed into fuel. Okay, it become coal, or petroleum. Okay, so coal fired engines already almost replaced. Okay, so but still some relevance will be there in heritage train or somewhere, only limited use is there for coal fired engine. But petroleum, or yeah, so coal may have steam engine also. Okay, but petroleum, you get initially you get crude oil. Okay, so crude oil, whenever you are drilling a hole or well bore, you are getting crude oil. So or gas plus oil plus sand. Okay, all this component you will get. You drill a hole from Earth's surface, well bore will be getting crude oil, natural gas. Okay, this is not oil, water. I should write water, gas, water, sand. All this mixture thing will come, but these things you cannot put into your engine. Why? Your engine will not take water. Okay, any well bore in its lifetime, whenever you drill a hole, you say oil and gas is there, maybe nearby under this IT campus. Okay, you drill a hole, you get oil and gas. Okay, so more water you will get actually. Your target is to produce oil or gas, but finally you will be producing more water actually. Okay, water is more available. Okay, so then, but water is not economical for your case. Water will not give heating value. You have to dispose is difficult because water, if it is containing oil particle, okay, crude oil particle or hydrocarbon particle, then disposing will be one big challenge. Okay, so when you are going for disposing, that means you have to remove all this oil particle. When you are removing, that is also it will take money. Okay, because lots of technology you have to use to remove all this hydrocarbon particle from water. So this is not giving money, rather it is wasting your money. Okay, so our target is to produce oil and gas, not water. Okay, but you cannot avoid it. Okay, then you got oil and gas and water or sand, you have to separate on the surface. Okay, so oil, well bore to you are getting on surface. Okay, from well bore, oil and gas you got on surface, then surface separator system will be there. So what is the purpose of separator? Separator will be separating oil, gas, water, sand. Okay, there are different mechanisms to separate oil, gas, separate. Again, water you got separately. Okay, now water you have to remove all the hydrocarbons, then you can dispose. Again, dispose randomly not possible. There will be certain government regulations, you have to follow that. You have to drill another hole, you have to inject there. Okay, so there are different mechanisms to dispose water. Sand also will have same issue. When you are producing oil and gas, sand also will come. So disposing sand also one challenging job because it will have hydrocarbon. Okay, so hydrocarbon coated sand, you have some noise. Okay, yeah, hydrocarbon coated sand disposing is very difficult. So again you have to separate the hydrocarbons. Okay, then dispose. Now gas. So gas, lightweight, life is beautiful, you are getting gas, fine, but gas will contain hydrogen sulfide, carbon dioxide, okay, water, moisture content. So whenever gas you are burning, let's say Indian gas at your home, so that will not contain H2S, CO2 or water. That means you have to remove those contents. Okay, natural gas you are getting from well bore, and you remove these harmful gases, hydrogen sulfide, carbon dioxide and water. Okay, then you can use the gas. And oil, whatever oil you are getting, that oil may contain H2O, small amount of H2O also not allowed, may contain some mud or sand. Okay, sand or mud may be contained, so you have to remove those things. After that you can use. Okay, so then you got separated oil. Oil is not having mud, water or sand. Now some salt content also may be there. Salt content, some heavy metal salt may be there. So that also you have to remove. So after removal, that you got crude oil. Crude oil is very thick actually. So after removal or everything, you got thick crude oil. What do you mean by thick? Thick means high viscosity actually. So water is viscosity 1, but oil viscosity will be 20, 100, 1 lakh, 1 million also possible. Some crude oil will have properties such that it will not flow normally, okay, like grease, toothpaste, that much of thick, okay. So very thick fluid, high viscosity. Now you have IC engine, injector or carburetor, whatever is there, this thick fluid will not flow through this, okay. Then you have to do something so that it will be flowing into the engine, okay. Again, this thick fluid may contain still sulfur content, some amount of sulfur. If some amount of sulfur is there, sulfur will be reacting at high temperature with oxygen, so it will contain S plus O2, SO2, and another form will be there, SO3 also, okay. So I am not balancing this one, you can do balance. So sulfur dioxide, sulfur trioxide also be produced. Now you have water content. If that thick crude oil is having certain amount of water, then what will happen? H2O plus SO2 or SO3, it will form H2SO4, H2SO3, okay. So H2SO4, H2SO3 is the acid will be reacting with metal, okay. So sulfur dioxide is there in atmosphere, it will be harmful, very much harmful. If it is having beyond certain limit, then people can die also. If you are smelling sulfur dioxide directly as H2S, hydrogen sulfide, you can die, okay. If you have acid also, it's very much dangerous. If you concentrate sulfuric acid or sulfurous acid is there, that is also very much dangerous. Another way it is dangerous, it will be corroding all the metal part, okay. So it is harmful for environment, harmful for your machinery also. So if you have any sulfur content, you have to remove. Carbon dioxide may not be so much harmful, but it is not giving any heating value, and again it is acidic gas, so you have to remove the acidic gas. Acidic gas means the gas reacting with water, it will be forming acid, carbonic acid will be formed, okay. So you have to remove carbon dioxide, H2S, water also you have to remove, because water is not giving heating value. Later I will discuss why water is important. When you are calculating heating value of fuel, this will be giving lower calorific value, okay. Later we will discuss. So whenever you are getting crude oil from wellbore, you have to remove all the particle, then finally you get a thick fluid crude oil. It is having very less amount of sorry, water, sulfur dioxide, hydrogen sulfide, all these things, okay. Now the thick fluid also you cannot put into your cylinder, then what you have to, maybe you have to increase temperature and you have to change viscosity, okay. So this crude oil increase temperature, so whenever temperature is increased, viscosity will be down. Viscosity low means again it will be flowing, okay. So flowing means then you can inject through injector port to your cylinder, it can be burned like diesel fuel, okay. So this is the story of whole crude oil from wellbore you are getting for your engine. So normal petrol or diesel, this is highly purified or refined fluid for your IC engine you are running, for your bus, truck, bike, car. But this crude they call heavy fuel, HFO, okay, heavy fuel. So heavy fuel oil, so heavy fuel oil have more viscosity, and sometimes many agencies they are saying these are very harmful also, because very thick, that's why some sulfur content and other content will be there. So combustion may not be proper and it will be producing harmful gases. So many agencies they are saying, okay, don't use heavy fuel, okay. But it is cheaper, because you from refinery you do not need to refine properly. So some thick fluid, some other content also there you can use for your engine, okay. Normally this will be used for diesel engine, okay. This is for diesel engine. Okay, over time, okay, you see crude oil formed over millions of years from the remains of plants and animals that lived in the seas, and these organisms died, they sank in the bottom of sea, were buried under the mud and sand, creating an organic rich layer. Over time, this layer kept piling up, forming sedimentary rock, and organic remain turned into oil and gas droplets. The oil and gas eventually moved through a porous rock and got trapped by an impervious layer of rock, accumulating the highest point. So if you want to know more about this, how this is getting formed, then you have to go through Wikipedia or other document. Okay, this is not our within our syllabus, thus I am not going into details. Fine. Okay, so marine engine, you may have guessed, okay, this may be your engine. So just I got this information from Ashok Leyland website. Okay, this is their engine specification for marine ships. Okay, so you can see, so 4 inline cylinder is there, number of cylinder. So one cylinder is here, and 4 inline cylinder. Inline cylinder means one cylinder is here, another cylinder. Just wait. I was drawing like this, you can remember. This is your crankshaft. Previous lecture we discussed already. This is your cylinder. Again, this is your cylinder. This is your cylinder. Then one more cylinder will be there. Okay. So these are bearings. These are bearings. These are bearings. These are bearings. Okay. So one common crankshaft and 4 cylinders connected. So one crankshaft is there, 1 cylinder, 2 cylinder, 3 cylinder, 4 cylinder. Okay, 4 cylinders connected in a series. So this is called inline cylinder. Okay, and some other type of cylinder already we discussed. I think remember this cylinder is here, cylinder is here, cylinder is here. Radial cylinder we discussed. Okay, so this is not radial type, this is inline type. In one direction, all the cylinders should be there. Okay, and shaft is common. This is crankshaft. Okay, I have written already. These are the bearings. Okay, and rated power in kilowatt, 41 kilowatt, 2000 rpm. You can see rpm is very high, 2000, right? And 20. So you can guess the rpm range 2020 2800. Okay, so displacement 4 liter displacement, the piston displacement. Okay, 4 liter it will take. So big engine. And bore into stroke. Bore means this is stroke length, cylinder stroke length, BDC to TDC, you can remember. And bore means diameter, 104 millimeter and 118 millimeter. Okay, flywheel also there, you can see this. Okay, and maximum torque 250 Newton meter for 1800 rpm, and torque and rpm if you multiply, then you will get power actually. Okay, this is torque, this is N, then power equals T into omega. Okay, so you can get power there. So fuel injection type, mechanical, inline pump is there. So this is for sure diesel engine, so inline pump is there. Okay, so naturally aspirated we will discuss later. Naturally aspirated means how breathing or cooling is happening. Okay, coolant type, seawater coolant is used. Okay, we will discuss later when we will discuss about cooling, engine cooling. And okay, marine engine size is there. Gearbox also they are using DMT something, so it is their notation. Gear ratio 2:1, 3.32:1. Okay, so they are reducing speed to half. Okay, marine diesel engine, you can see marine diesel engine assemble, hydraulic gearbox they are using. Okay, and application, main propulsion engine for small craft or auxiliary applications. Okay, coolant type 10 liter cooling fluid volume is required. And starting system, electric starting, you say 12 volt DC starting system is there, so spark plug will be there, so 12 volt DC you have to supply. Charging alternator means generator. Okay, 12 volt 36 amp, so power equals P into V, you can calculate V into I. Okay, engine dry weight without gas 380 kg. Okay, so you got the idea of one engine, how big it can be and what are the different parameters will be. Okay, now just I took some example engine. This Titanic engine already is very much familiar to you. Weight was 1000 kg, height 30 feet, you see this high pressure cylinder, low pressure cylinder, so different types of cylinders were there. So initially we got steam, it was steam engine. So initially you got steam, so steam it will go to high pressure engine, then same steam you are pushing to another cylinder, so pressure is going, every time it is going lower, lower, lower. So you have multiple cylinders actually. So that's engine, steam engine. I'll discuss later in other lecture, other chapter. Okay, 75 inches stroke. Stroke means TDC to BDC the distance, 75 inches. Okay, 75 means 5 feet, 6 feet. It's almost my height, I think. Right. Operating speed 76 RPM. Okay, this is propeller speed most probably. Operating output 1600 HP. So this conversion also you should remember, horsepower means like 746 watt. Okay, this conversion sometime I will be giving horsepower data, sometime I will be giving kilowatt data. So you have to convert from here and there. Okay. So another example I am giving here, icon of the sea. This is a new ship, cruise ship. The design is very large actually. You can see 3,286 passengers will be there. So many bars, lounges, swimming pools. Very big ship actually. Okay. The ship was constructed Royal Caribbean, and they will be using LNG, liquefied natural gas. Okay, liquefied natural gas, and CNG. This is compressed natural gas. Okay, LNG means you created liquid. CNG means you did not create liquid actually. It is compressed. Okay. So your Indian cylinder at home in India, they are supplying compressed natural gas, CNG, right? These engines can be operated using both LNG and distilled fuel. Distilled fuel means like heavy fuel. Okay. Furthermore, the ship has 6 dual fuel engine that LNG can be also powered. Okay. So this is a dual fuel engine. So big, so heavy. So this engine will not be powering only for propelling, it will be giving power for everything, like so many bus and so many passengers. For everything it will be producing power. Okay, one engine it will be producing power for everything. Like whatever water purification is there, your engine comfort like air conditioning system will be there, engine cleaning system will be there. So all water production, electricity requirement, everything will be produced by one engine. Fine.